So, in the previous video, we derived the overall expression for the ideal case when there are no disturbances, there is no model plant mismatch, there is no unmeasured disturbances. But now, if we have disturbances which are measured, those disturbances get added in the form of dk, okay, and then we need to take care of these measured disturbances. Now, where do these disturbances come from? There are various ways in which we have learnt how to do the modeling in week 2 and week 3 of this course. Okay. One of the ways we have seen is the first principles model. So, what do? We write ordinary differential equations in order to model the system, and the ordinary differential equations are of the form dx by dt is some function f of x comma v. I will just write it as f x comma v over here, okay, where v's are input variables, okay, and we linearize, okay, and when we linearize this, we will get dx by dt, or let us say we say dx dash by dt equal to ac x dash plus bc, or AC bar, I will just put bars over here, BC multiplied by V, okay. So, or V dash, this is what we get. Why? Because we are just in the deviation variables. Just to make notational simplicity, we will just remove the dashes over here. Now, V itself, inputs are of two types, okay. One that you can manipulate are manipulated inputs, one that you cannot manipulate, but you measure and you model the effects of them, those are called measured disturbances. Okay. So, we can write V as nothing but u and d, and therefore, we should be able to write a bar c x plus b okay, and this will basically yield us ACX plus BCU plus multiplied by B, okay. When we discretize this, we are going to get xk plus 1 equal to AXK plus BUK plus BDDK, okay. So, this is how we obtain first principles model, okay. What was the other way that we followed, and this was again a part of your week 3 of your course. In week 3 of the course, this is what we did. We had our u, right. So, this is how we model this, okay. You then had an home assignment problem where you had to take one single input single output model, another single input single output model, and put them together. How did we get those models? We got those models of the form of x k plus 1 x d k plus 1 will be equal to a 0 0 a d plus So, this is what we did. This was a part of your home assignment problem. So, this should probably be familiar to you. Okay. So, the first principles model, we actually build a model. For example, let us say inlet concentration and inlet flow rate are the two inlet variables. Okay. Inlet flow rate is a manipulated variable, inlet concentration is a measured disturbance, inlet flow rate becomes a part of U, inlet concentration becomes our D. Okay. So, now same way we can look at the obtaining this from transfer function model, and you get a transfer function structure as shown over here. And the third one is by doing step tests. What do we do when we do step tests? We do step tests in all the inlets and all the outlets. So, whatever are the manipulated inputs, those become our manipulated variables, whatever are not the manipulated inputs, those are the measured disturbance variables, and we build our model from that. Okay. So, that particular model we are just going to build it in the form of y equal to SU multiplied by delta U plus SD multiplied by delta D. Okay. And this is how we build a database model based on the step test. In the same manner, we will build up database models for from the overall test equations, and that is a part of a different course which is called system identification. So, I will not cover that particular part in this particular course, but whether it is a first principles model, transfer function model or database model, finally you will get your overall model in this particular form as shown over here. Okay. So, now when you have the model in that form, what do we do? Now, we want to build the overall structure in exactly the form that we covered about it in the previous video. Okay. Now, what is the difference between U and D? The primary difference between U and D is U can be manipulated, D is not manipulated, it is just a measured variable. So, it follows the same structure, and the structure that it is going to follow is that Yp is going to be nothing but Sx multiplied by Xk plus Su pre multiplied by Uk minus 1 plus S capital U multiplied by delta U and K, okay, plus we are going to have this same structure over here, Cb C multiplied by Bd, Cb plus Cabd, Cbd plus Cabd plus Ca square Bd and so on, right. So, that is what we are going to have. So, the first row is going to be C multiplied by Bd. Next one is going to be Cbd plus Ca multiplied by Bd. Okay. The third row is going to be Cbd plus Cabd plus Ca square Bd, okay, and so on up to summation I equal to 0 to p minus 1 C a to the power I multiplied by Bd. Okay. Likewise, we will have something over here and so on, and then we are going to have delta dk plus 1 and so on up to delta d k plus p minus 1. Okay. But if you recall what we have done in week 4 and 5 of this course, delta dk was a known quantity, but delta dk plus 1, delta dk plus 2, delta dk plus 3, we all took them as all 0. Okay. Because by definition we have taken them as 0, we can just delete all of these guys, and correspondingly we can delete all of these columns as well. Okay. Again, straightforward linear algebra, you can recap the thing that we did before the start of the course in week 0 of this course, and it will be very clear to you that the form of the equation is going to be something like this, where this is SB. Okay. So, how do you take care of measured disturbances? You take care of measured disturbances by including this particular last term in what we have done in the previous lecture. Okay. So, with that I come to the end of this particular video. Okay. What we have done in this relatively short video is showed how to handle measured disturbances in the overall framework. Okay. In the next video I am going to talk about how to handle unmeasured disturbances, model plant mismatch, modeling errors and all those things in the overall framework. Please keep in mind, so far all that we are doing is in a deterministic case. Okay. Later on we will come to the case where we need to handle stochasticity as well. Okay. So, with that I come to the end of this video.